Cool. So my name is Michael Jernigan. I worked with Dr. Cathcart and Dr. Alice Weiss on a project for AMI, the Advanced Mobility Institute here at Florida Poly. Had a lot to do with mainly sensors on autonomous vehicles and how we can characterize and test their accuracy. So starting off, let's get a little bit out of the way. The internship provided an excellent opportunity to connect coursework/classes, a lot to do with digital signal processing, systems and signals, obviously circuits, as well as a whole host of other coursework that you'll see a little further down. A lot of stuff that I was really interested going into this that I gained was a better understanding of sensors and how some of the sensor technologies work, especially near-infrared and infrared imaging devices, whether they're passive or active, or if they're just for range, like time of flight. LiDARs, for instance, are infrared, sends out a beam of infrared light, and depending on how fast you can get it back, that allows you to make sort of what's called as a point cloud. So if you've ever seen any of the autonomous vehicle I guess what would you call that? It's a video of sorts, but different LiDAR companies, you'll see it looks like a 1980s Tron-like world, a bunch of different colors that are mapping out the surroundings around them. So that was definitely something that was interesting as far as what I looked into. As far as total research project, it was pretty large. It sort of changed halfway through. At first, it just began as an initial survey on some of the autonomous vehicle testing facilities that are out there, whether they were part of the Department of Transportation's 10 designated test sites, some of the private test facilities, whether they're GM, BMW, Volkswagen, as well as some of the other international players. From that, the goal of sorts was to sort of design a test roadmap or a testing approach to how to fully test all sensors as well as an autonomous vehicle as a whole at one time. Up until now, whether it was an anechoic chamber or certain test benches, it's all been mainly testing and verifying or characterizing these sensors on a sensor by sensor basis, nothing that has really been all encompassing with the autonomous vehicle. And that's important, and we'll see a little bit more why as far as finding certain edge cases where certain sensors might fail over others, or some of the different data values that are going to the brain of the computer or the autonomous vehicle, if you will, and how they're making their different judgment calls on what's what and what data should be more relevant than others. So, 20 minutes, forgive me, I'm going to skip a little bit. Yeah, it's a lot. Autonomous vehicles. So aside from the initial survey of all the different testing facilities and their capabilities, we got into, which I think is the most important, it's the one I worked the most on.
What was the gap analysis outcome from the test facilities? What did you identify as the gap?
That's a good point. Where did I find that? The biggest gap, I can tell you from memory, the biggest gap was a lot of the different test facilities, whether they were open track or environmentally controlled test capabilities, they didn't have the ability to test numerous sensors on an AV at once. So if it's on a track, let's say, for instance, the SunTrack facility, the 2.25 mile oval test track, you can only control your environment so much when it's out in the air. So interference, especially for what's known as V2X or vehicle to everything communication, telecoms, anything to do with communication with vehicles, with satellites, with networks, you can't really control that if you're wanting to test for something like interference. So they have what's known as anechoic chambers. If you've ever seen a large, looks like a foam room of sorts, it's really just a large rectangular room. Some facilities have that, where some don't. But the problem again with anechoic chambers, they're usually either designed to be tested for sound, or in our case, more importantly, EMC and EMI issues. So especially interference when it comes to certain devices. So the biggest gap, to answer your question, there doesn't exist a facility or a test chamber that can fully test all of these different sensors at once. So that was actually the goal that we sort of put up to address, and let me jump to that for you real quick. So I mentioned anechoic chambers, and the problem is that you can only test so much. So let's get to some slides so I can show you. Atop, you can see what's a OTA anechoic chamber or over-the-air test chamber. Any type of antenna characterization, emissions testings, or any small electronic devices like your cell phone. I believe that's actually a picture of one of Apple's smaller test chambers. They're usually catered for one thing. They're only testing for one thing. You really can't change up the test scenario aside from injecting some type of signal or changing the position of the antennas or your sensors per se. So our goal for that was to design a chamber, innovative test chamber for AV and related technologies that currently didn't exist. Some of the main things that we needed was a chamber that could support and test characterization of multiple scenarios as well as across multiple sensors. And that's something that we actually designed, and I'll show you a little bit about that. This is a generic two-dimensional facility concept layout of what we were looking for. One of the more interesting things is the shape of the actual chamber. If you see the anechoic wall segments, most anechoic chambers, they're just large boxes. They're either rectangular or square boxes. The problem with that is different types of chambers can only test certain things. So for instance, millimeter wave radar that is found in autonomous vehicles, you can't test that at the same time or even in the same test facility as something that might be used for testing over the air or antenna characterization or even radio interference signals. So with the wall segments, our initial idea was, what if we could change or morph the shape of the testing chamber, and what would that look like? So this is one of the first or preliminary sketches that we came up with to how do we put an autonomous vehicle or a sensor itself in this room, and how can we test as many scenarios and as many sensors across the board at once. So here's a better view of the actual testing chambers in the dual wall design. One of the sides of the chamber would be more dedicated for V2X testing and characterization, and the other one would be more for millimeter wave radar. The biggest thing is the range or the patterns of the anechoic foam wedges. They have to be designed for certain sensors or certain things you're testing for at once. Each of our wall-mounted segments pivot to allow for the anechoic wall to be oriented in the chamber. So for instance, to actually enter and put a vehicle in there, we have to open it up somehow, as well as just the 360 or 180 pivot. When it comes to radar, we had to add a little bit more. So for radar, we used Radar Target Simulator, or RTSs, to emulate various objects and responses to radar signals. And you can see that in the little highlighted section in the bottom. These are all tracked sensors or tracked mounting pods that we could put various sensors to either inject signals or to test different things that are coming back off of the vehicle itself.
Is that at the bottom? Not sure I understand that. Essentially a mounting?
Oh, that's a note. Ignore that.
Okay.
That's a note.
Understood.
All right, going on something else. So we had the radar. The next thing that we needed to characterize or test at the same time was camera. So the problem with testing cameras in an anechoic chamber or any visual sensor is anything that you're going to put in an anechoic chamber.
Stays there.
Well, it's especially with radar, it's going to have some type of bounce back. You're going to have something that is either going to deflect the signal or it's going to cause some miscellaneous interference that you weren't expecting. What they're currently using now in some of the autonomous vehicle testing facilities is literally like an old-fashioned projector screen, and they're mounting projectors directly on top of vehicles to project some type of driving scene so that the autonomous vehicle can recognize that. The problem with that is not every vehicle is the same shape or size, and it's hard to have some type of uniform test capability when you're going around mounting projectors on vehicles. So what we came up with, and I need to mention as well, this is all conceptual. What we're going to continue to do into the fall is further research some of these different test approaches to iron out some of the proposed ideas for these solutions. But what you see here, as well as the 6 degrees of freedom vehicle platform, the recessed projectors off to the left of the screen there, you see sort of a panoramic hollow projection screen. So our goal for this is, how do we project more than just a blank screen or a TV screen? How do we give the autonomous vehicle sort of a view of a simulated environment while testing everything else? And what we came up with was a panoramic hollow projection screen that also would not interfere with any of the other sensors. So mainly with that, the biggest issue is the radar, right? So it has to be designed out of something that has low attenuation or is essentially transparent to radar. So like radome materials, if you've ever seen like the front of an airplane or a weather radar, radome, usually some sort of hexagonal shape of sorts, that's what that's made out of. And it allows for the radar signal to go out, come back in, and it doesn't cause much attenuation in the signal or interference. So that was the goal of the camera testing capability within the test chamber. The next thing to mention was EMI, and more specifically EMC testing and characterization. So some of the things that we put inside of the test chamber, in addition to the pano screen, the embedded rails where we can articulate different tracked or motorized mounts, was a way to address the EMI and EMC. This is one of the open issues that we have that we're going to do further research into, because it gets complex. If you think about different things on board vehicles or different interference sources, needless to say, it's an issue that's not been addressed for AVs yet. One example that I could give, if you think about some of the electric vehicles that are wanting to charge themselves on roadways, that charging in effect is a large interference for any of the other sensors on board an AV. So that's one thing that they're looking into now as far as a broad field issue. But that's one of the capabilities that we wanted to design into the chamber. And that essentially is just having the flexibility within the chamber to have multiple signal injection sources, and how can we create interference and test that feedback on the AV side. In addition to that, I mentioned V2X. V2X, you can sort of think of it as if every vehicle had a cell phone. And if you have all of these different cell phones on vehicles, and that might be a bad example, but we'll go with it. What type of interference are vehicles going to have when you have not only radar signals bouncing around, you have environmental issues or environmental interference sources with all those sensors. So a way that we wanted to address that as far as testing and how can we characterize some of those problems is these motorized TXRX modules that you see mounted on these arched rails that allow us pretty much 360 rotation around a vehicle under test. In the grand scheme of things, with all the other capabilities for testing. So those are mainly going to be used for signal injection. So
What was VOD? VOD?
V2X
You had was it FOD? You had an acronym earlier.
DOI.
or Department of Transportation, DOT?
You're talking about the platform which had 6 degrees.
Oh, degrees of freedom, 6 degrees of freedom.
I'll just make sure that it's
Yeah.
all right.
So basically, if you've ever seen like a flight simulator, and they have some now currently for vehicles, it's just something that allows the vehicle to be manipulated or articulated in 6 degrees of freedom. So that's V2X. LiDAR testing, that was one of the hardest things that we could address. Currently, there's nothing on the market, or there's no company that is addressing how to characterize or test LiDAR aside from traditional optics testing benches or platforms. There's not really too much you can do. It's a time of flight system. It sends out a light source, and then it collects it back and times it. So what we sort of came up with, is there any way that we can remove from a LiDAR the ability to receive the signal back, and literally only use the outgoing source of the infrared light and project it onto some type of photodetector panel in the grand scheme of things within the testing chamber. And then with that, we can put different types of environmental conditions or different scenarios to test the accuracy of that LiDAR and compare it to what the manufacturer standards are. So that's also one of the other key points that we're going to be looking into as we go into the fall semester. But yeah, essentially that was my main job, was a lot of research on different test equipment, test facilities, and then thirdly was the design of this conceptual testing chamber, anechoic chamber. So a lot of revisions of different versions of the chamber. You can see here, a lot of work. It was fun though. Short of that, there's another few slides, but I don't want to keep you too much. It goes into our review of a proposal for test equipment. But if any questions, I would take those now.
Well,
I guess what I need you to show me is kind of a slide that describes and demonstrates meeting your identified learning outcomes.
So the biggest learning outcome, when we go to front, was to have a better understanding of some of the different sensor technologies. Dr. Miller's looking at my 100 slides, and she's like, oh my.
And once you show me your reference to it, now go to the slide that discusses it. If you could.
When you say discuss, going into detail some of the different,
Yeah, it just discusses how the work performed demonstrates the identified learning outcomes.
so that's going to be in that second slide.
So that's where you do it there.
Yeah, that was the outline.
Then,
I'm sorry, is your internship connected with the advanced mobility?
Yeah. And this is a part of a larger report that should be out by now. Very detailed, very long. But in addition to the initial research of the current testing facilities, current sensors in the market, and different testing approaches, the final goal was to design this conceptual chamber to check off all those marks.
so then, I guess, can you show me where you talk about the lessons learned from the internship experience? Kind of just follow this guy till it.
That depends what you mean by lessons learned. I can give you verbal. The biggest lesson learned for me, aside from some of the learning outcomes, definitely was time management. For this particular internship, it was sort of guided by Amy as a whole. We had weekly meetings, but for the most part, most of the work I was pretty much on my own to sort of go out there and do all of this research and come up with some of these conceptual test approaches.
Who guided you on a weekly basis?
Amy as a whole. So Dr. Rosden and the Amy group, the Advanced Mobility Institute, as well as Dr. Cathcart and Dr. Alice Weiss. They were my two immediate supervisors.
All right, I just want to make sure that. Good. So then, do you have a reference slide at the end?
Yes.
Okay, show me that. So similar to my previous comment, is that formatting is
Format,
good. You
correct.
need to format. That's just in case if that document goes anywhere,
Yeah.
make sure you connect all the pieces.
And this isn't the final document. This is just the version that I could get my hands on
Okay.
and put together. It's actually a 40-page paper.
Well,
It's hard to condense a lot of that information.
I just want to make sure that okay. And then the work that you did, the kind of project design or work results was really, you said, the effort to do the research and produce the report?
Correct.
Okay.
Correct.
All right.
So that was the three main components was originally coming up with all of the different test equipment, so surveying all the existing AV sensors, some of the different testing equipment that's out there in an effort to build out this conceptual lab, as well as the survey of all the existing testing facilities.
Okay, and then I guess the only question I have is, did you create this for this internship, this document, or was this?
Yes.
Okay. All right. Then I guess another thing is, you can go to slide 16 for me, please.
You have good eyes.
That's what I do. So, so here I see you talked about, kind of like I guess this is your ideal vehicle that might be part of this test environment.
Correct, as well as current vehicles and some of the sensors that they're equipped with.
Right. All the related components and stuff. Is this what you had in mind when you created that chamber?
Yes. In addition to that, though, we wanted to allow for some flexibility. One of the sensors that you'll see we really don't mention much is the ultrasonic, or the transducers. The biggest issue with that is it's something that we didn't see as being one of the concerns, or one of the major sensors that are being utilized for some of these decision making and AV decisions when they're on the roadways. Aside from parallel parking or curb detection, things of that nature, the biggest issue that we saw was definitely LiDAR, radar, and the interference, both environmental and intersensor interference between those. But
So-
yeah,
So then to speak of this is kind of where what you designed around and where you got your lessons learned in that process.
correct.
Okay.
As well as referencing some of the current testing chambers or testing facilities that are out there.
I guess my last question is, I think it's around slide 42.
Diesel,
So-
everything?
Yeah, here, actually go to the previous slide for a second. So there's open issue for session interface. So this is kind of hinting to your next steps?
Correct. That was one of the things that was added on as far as goals for the project towards the end. It's one of the issues that's a bit more complicated to address, and that's something that we sort of allude to in the final report. That's something that needs further research.
Well, thank you very much.